Dear students, now we are going to do a problem. Okay, it's the fourth problem in this lesson. See the problem. In a crystal lattice, X occupy alternate corners, Y occupy alternate face centers, and Z occupy all edge centers. Find the formula of the compound. Okay, so X, Y, and Z. Let us see. In a crystal, so X occupy alternate corners. How many corners are there? 1, 2, 3, 8 corners we know. 8 corners. Alternate corners means, suppose here it is there. Okay, it is not here. It is not here. It is not here also. And for this one, this is alternate corner. So here also it is not there. Okay, then second one, let us see this one. So he will place one atom here, 1. So this is alternate corners, this is not there. So this is not there. Here also it is not there. Okay, next one, we'll place here in this corner. So here it is not there, here it is not there, here it is not there, right? Now we are placing here 1. So it is not here, it is not here, it is not here. So alternate corners means, suppose you see here, this is the corner. For this corner, this is the next corner. So it should not be here. It should be somewhere else. Then for this one, next corner is this one. So it is not there. So here also it is here. It should not be here. So we are calculating. There is actually 8 corners. So instead of 8, in the how many corners are X occupies? Only 4 corners. Alternate corners. Alternate corners. Corners X. So how many are there? 4 into 1 by 8. It is equal to 1 by 2. Is equal to 0.5 we can take, or 1 by 2. Y occupies. Y occupy alternate face center. Alternate face center. Face centers. Y. So how many faces are there, you see? So alternate face centers. Normally, suppose here this is one face center. This is one face. So alternate, it should not be here, it should not be here, it should not be here, it should not be here also. It should be only here, this side. Or if it is here, it should not be 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 here. Only just opposite. So here you see in this cube, this is face, this one. Face center, 1. So next one, next face, here it should not be there. This also, here also it should not be there. Behind that also it should not be there. Here also it should not be there. Next one, it will be here. This is Y. Okay, so this is Y. So normally what students they do know, alternate means 6 faces, they take it as 3. So but here Y only 2. 2 into 1 by 2 is equal to 1. This is half. Right, next one, Z occupies all edge center. Z at edge center. Edge center. So how many are there edge center? Edge center, how many edges? 12 edges into 1 by 4. Already we studied this one. So what will come here? 3. Okay, so we'll write this one. X 1 by 2. Y, what is this one? Y 1. And Z is equal to 3. This is actually number of atoms in unit cell. So it cannot be in fraction. So we have to find out the formula. For formula, we are multiplying this by 2, this also into 2, this also into 2. So how you get this one? X 1, Y 2, Z 6. This is actually formula of the compound. Formula of the compound. Okay, this is the answer. Next one you see here, what we are written? 1 by 2, here 1 and here 3. This is actually atoms present in the unit cell. Number of atoms. Number of atoms present in unit cell. Present in unit cell. This is very, very important. This is also very important. This, I think you can do this one. This, when you have to find out the density of the unit cell or something, in that time you should not take this formula. You should take how many atoms are there in simple one unit cell. Okay, so this is over. Next one, we can go for different types, tetrahedral sites and octahedral sites. Okay, so let us give the topic for this one: sites, tetrahedral and octahedral sites. This already we studied in stacking in three-dimensional packing. Okay, so first one is tetrahedral voids. Tetrahedral voids. Okay, in tetrahedral voids, what is happening here? Which one we have seen? This one. This is number 1. This is number 2. This is number 3. This is actually tetrahedral voids. Okay, this is tetrahedral void. Tetrahedral void. Okay, voids, the shape of the void is not tetrahedral. Actually, what is tetrahedral? The arrangement of atoms or sphere. So, suppose for example, you are placing one sphere on this one. Okay, when you are placing one sphere, so the void here. So, how many spheres are there? 4 spheres. So, when you go on arrange that one, you will get here also top also one sphere will be there. As a result, bottom also one you are stacking on above. So one sphere will be on the top of the tetrahedral void, one sphere will be on the below the tetrahedral void. So this is actually tetrahedral voids. Okay, next one. Second one is number 1. Second one is octahedral voids. So tetrahedral voids, you see, if you in the textbook it is given the diagram. If you see this one here, this one you can, this is tetrahedron. Tetrahedron. Okay, I think you understood. Next one is octahedral voids. So let us go for octahedral void. Octahedral voids. Octahedral voids, you see, actually one sphere here. We are placing this one here, 2 here, 3 here. Right? So what is this one? Below 2, up 1 in one row. The next row, how it comes here? Above 2. So that we can use different colors. Okay, above this one, top this one, you see you are using 1, here 1, then here also 1, 2, up 2, and below 1. Okay, it should come exactly here. So this is actually octahedral void. Octahedral voids or site. Voids or site. Already we studied what is voids or sites. What is actually octahedral voids or site? Site or interstitial sites or voids. We assume all the particles are in sphere. So when we are stacking sphere in 2-dimensional or 3-dimensional, there will be always some vacant spaces are left. Those vacant spaces are called voids or site, or we can say interstitial sites. Okay, so this we can understand this one. So just we can draw this one, these 2 equilateral triangle. So how you get this one? This is 1 here, this is 2 here, this is 3, third one. Second one you are placing 2 here. Next you are placing 2 here. So this is 1 here. Next sphere is here, 2. Next sphere on top, it comes here, which one? Third one. So this is octahedral void. Okay, if you want to draw this one, we can draw like this one. We can take this one, here one triangular shape, here also one triangular shape. So okay, so we are connecting this one and this one. It's a 3-dimension, so a little difficult to exactly draw this one. So this is octahedron. Octahedron. Okay, so whenever we say, when we see that the close packing in 3-dimensional, so there are different types of voids are there. One is octahedral voids, second one is tetrahedral voids. Now see here, for one sphere, very, very important point, note down. Number 1, for each sphere, each sphere, or we can write this one n sphere. For n sphere there are n octahedral voids. For each sphere n there are 2n tetrahedral voids. Is it clear? So the previous video we have studied this one when we are stacking in 3 dimension. What is happening here? When we are arranging each sphere. If you observe each sphere, diagram is given in NCERT textbook. Each sphere, around each sphere there are 3 tetrahedral sides and 3 octahedral sides around. This is the third point, very important. Around each sphere there are 3 octahedral voids and 3 tetrahedral voids. Okay, now what we studied, we have studied what is tetrahedral side, how it appears. Okay, how octahedral side appears, then what is the structure of this one. Okay, so if you see for tetrahedral sides or octahedral sides, if you see this one, the coordination number or the octahedron or the select sodium chloride, their coordination number will be 6. Okay, so tetrahedral sides, how it appears, then these are actually, it's very important points. When we do the problem now, we require all these things. Okay, so the remaining thing we'll see in the next video. We'll do some problem based on tetrahedral voids and octahedral voids. Okay, thank you.